Alright, so section 13.2 is actually kind of an extension of 13.1. It's on verifying or proving. Verifying is another name for proving trig identities. And remember, we have kind of two things to help us here. We can use this sheet that has all the different identities on it. And the most important ones are probably the Pythagorean identities. Those are the ones we use the most. And then we have this sheet that gives us kind of basic strategies, and there are 4 of them. First of all is whenever, basically we'll talk about in a second what an identity is just to recap, but whenever you're proving identity, you always start with the more complicated side. The goal with an identity is to show that the left side and the right side are identical. That's what identity means. How do you decide which one to start with? You always start with the harder side, the more complicated looking one. It's easier to change something complicated to something simple. So 4 basic strategies, that's the first. The goal of proving identity is make the right side look identical to the left. Start with the more complicated side. Try to make those well-known identities appear that we talked about in section 1. And then all the normal algebra techniques we're used to using, factoring, using what's called the conjugate, those are all in the game. We can use any of those. If we're really stuck and we don't know how to make the left side the right, we can change the left a certain amount and then try to start changing the right and see if we can make them meet in the middle. That will be enough to prove it. And the last strategy is, when you're in doubt, if you're really stuck, change everything into sines and cosines, and usually at that point it will become clear. Okay, just to recall, what's the difference between an identity and an equation? The top one here is an equation. We can solve that and we get a single solution for x. Okay, you could have more than one solution, like this one. We'll end up having 2 solutions. But the point is, equations are only true for some x values. Identities are true for all x values. So if you were to distribute this x right here, 2x minus x is x. X plus 3 is identical to x plus 3. It's always identical to x plus 3. There's no x value that you could plug in where the left side would not be equal to the right. Whereas at the top, there's a lot of x values. This one is untrue for any x value except for 2. So here's the idea. We're trying to prove identities, which means changing the left side into the right side, making them look identical. Okay, question is, our first strategy on that sheet says start with a more complicated looking side. The left one definitely looks harder, so we'll do that. There's 2 ways you could do this. You could either use the conjugate of 1 minus cosine, which would be 1 plus cosine, or you could factor the top. I'll show you both ways. So let's start with the conjugate first. What's the conjugate of 1 minus cosine? It would be 1 plus cosine. Okay. So now let's multiply this out. So if we FOIL out the bottom, 1 times 1 would be 1. The outside, this is a difference of squares. So 1 times positive cosine will be plus cosine. 1 times negative cosine is minus cosine. Those will cancel. And then negative cos times positive cos will be negative cos squared. And then we still have sine squared on the top. So that's what we have. Again, we're trying to make it look like 1 plus cosine right now, so we have to kind of think about how we're going to do that. Sorry, top is supposed to be sine squared times this. Okay, well notice we have 1 plus cosine. That's what we want. So all we have to think about is how can we make that other stuff disappear. And remember, when you see sine squared, and when you see anything squared, you should probably think of this Pythagorean identity. That's the most common. We use 1. So what is sine squared equivalent to? Well, if I were to subtract cos squared, I would see sine squared equals this. So I'm going to replace this thing with 1 minus cos squared. We still have it being multiplied by 1 plus cos, and that's over 1 minus cos squared. So notice 1 minus cos squared divided by itself equals 1, so we're left with 1 plus cosine, and that's how we proved it. We're done at that point. It says verify that it's an identity. We did stuff to the left side and we made it turn out to be identical to the right side. So you stop right there. The solution to this problem is you showing the work that made those 2 sides identical. So that's using the conjugate method. I just want to show you that there's probably like an infinite number of ways you could solve this. So that's kind of the hard part. It's not like that x plus 3 equals 5. Where is that? There's only one way to solve this equation right here. It's by subtracting 3. Okay, with identities, there's many different ways to do it. So I'm going to show you this one right now. Whoops, this is the factoring version. So I look at this sine squared and I think of this identity right here that we use so often. And I say, is there something that I could change? Like I know I want to end up with a 1 plus cos somehow, and that's a sine. So let me see if I can change this. So I see that 1 minus cos squared, that's the same as sine squared. So let me try that. I'm going to change the left side. I'm going to change sine squared into 1 minus cos squared. And I have it over 1 minus cos. And then it says factor. I notice that this looks like a difference of squares. Okay, that looks like a difference of squares. And to recall, this might not look like a difference of squares to you. So here's what a difference of squares looks like. If you had x squared minus 25, this is a square, and so is that. And it turns out to be x plus 5 times x minus 5. So if you look at these right here, the 1 is a square, it's 1 times 1, and cos squared is a square, it's cosine times cosine. And then how do I make the difference of squares happen? 1 has to be plus and 1 has to be minus. So notice now we have 1 minus cos over itself, we're left with 1 plus cosine, and we're done, because that's what we were trying to prove. We're trying to prove that that left side was identical to the right side, and we just did. So the whole goal of this process is pick the more complicated side, do stuff to it, do math operations like factoring or conjugates or many other things, and make the left side identical to the right, or vice versa, make the right identical to the left. Okay, a lot of these are just about practice. So in this case, we have to verify this identity right here, and not necessarily obvious what to do. Well, we see a cosine squared right here. Okay, and let's just go back to the strategies for a sec. So first strategy is start with a more complicated side. Okay, we have to decide on that. Try to make well-known identities appear, like sine squared plus cosine squared, and then when in doubt, change everything to sines and cosines. Okay, so in this case, I see a cosine squared, and I also there's also a strategy that says when in doubt, make these well-known identities appear. So actually, when I look at these, I'm usually just as clueless as somebody else in terms of knowing where to start. Sometimes you have to really think about, there's many different strategies that you can use here. So here's what I'm thinking. I have a minus here, and I'm not quite sure how are you going to get things being multiplied to end up with things being subtracted. Well, let's look at this identity. Let's change the cos squared into 1 minus sine squared, because you can do that based on this identity. If we subtract sine squared, cos squared equals 1 minus sine squared. So let's take the left side. This is not the only way you could do this, but here's one way. Let's change cos squared into 1 minus sine squared. Why did I do that? Because first of all, I see a minus right here, and now I have a minus here, so now that looks promising. The other thing is I know that I wanted a cotan squared, so I know I would have to multiply cotan squared by 1. That's going to give me what we want. So cotan squared times 1 would be cotan squared minus, and now if I distribute to that, minus cotan squared times sine squared. Actually, let me write that over here just so you can see it more clearly, because it's not clear on that red. Okay, so now I'm here and I'm not too far away. I have the cotan square, which is what I want right here. How do I get that other thing to be minus cos squared? Well, when in doubt, we said change everything to sines and cosines. So let's change this thing into, this is an identity, minus cos squared over sine squared, and now maybe you see what's going to happen. These will cancel, and we're left with cotan squared minus cos squared, which is our proof. Okay, again, that's not the only way you could have done that, but that is one of several strategies. Okay, simplify. So this is like we did in 13.1. When in doubt, change everything into sines and cosines. So let's do that. So cosec is the same as 1 over sine, and tan is the same as sine over cosine. So if I'm dividing, first of all, let's multiply these. That's the same as cosine over sine. And dividing by that fraction is like multiplying by the reciprocal. The reciprocal of sine over cosine is cosine over sine. Cosine times cosine is cos squared, and sine times sine is sine squared, and this is an identity. Sine over cosine is tangent, and the reciprocal of that cosine over sine is cotangent. So cosine squared over sine squared would be this right here, cotan squared. Alright, we have a whole bunch of them here, so let's do both of these. Let's start with the top one. Obviously, like it says, the bottom one's a little bit harder. So cotan squared minus sine squared, let's distribute this. So we have tan squared times cotan squared minus tan squared times cosine squared. Well, these are reciprocals right here. Tan squared, or cotan squared, is the same as 1 over tan squared. So those are going to cancel, and that just leaves us with 1. And then when in doubt, change everything to sines and cosines. So I'm going to change So I'm going to change this thing right here into sine squared over cosine squared. And then I have that times cosine squared. Those will cancel, leaving me with sine squared. So this whole thing is sine squared. So we have, sorry, that's a mess right there. We have 1 minus sine squared, and you might recognize that from this identity. Like I said, it appears all the time. So if you haven't memorized it, hopefully you'll see the need to. If we subtract sine squared from both sides, we end up with 1 minus sine squared is equal to cosine squared, so that's option H. Alright, let's take a look at this next one right here. So how are we going to do this one? Whoops. Okay, let's think about this. Let me clear these annotations here so I can have some more space. Alright, so here's what we want to do. We want to start by taking the more complicated side. Well, they both look fairly complicated, so I'm not sure that's going to help us too much. But usually the more complicated would be the right side because of this minus right here. That tends to make things slightly more challenging to deal with. Okay, so let's look at our strategies. Start with the more complicated side. We said it was the side 1. Okay, second go-to strategy, try to make well-known identities appear. So let's look at the right side. There is an identity that involves sec squared and tan squared, so I might want to take advantage of that. And just to remind you what that is, on our sheet, the Pythagorean identity, it's on the top left right there. Tan squared plus 1 equals sec squared. It's this one right here. Sorry, I didn't mean to highlight that. So tan squared plus 1 equals sec squared. So let's see if we can leverage this somehow. So we have a sec squared right here, so let's solve for, actually it's already solved. Sec squared equals tan squared plus 1. So I'm going to take that, I'm going to replace it with tan squared plus 1. And then we have this minus tan squared right here. And that's all over cosecant. So tan squared minus this tan squared, those are going to cancel, and we're just left with 1 over cosecant. Okay, 1 over cosecant. Well, that doesn't really help us too much because that doesn't look anything like the other side right now. Okay, so now we can go to, this is kind of a good example for this, another strategy. This is section, sorry, which strategy is this right here? Oh, here we go. Strategy 3. You can also try changing both sides and seeing if you can make them in the middle. Here's a great time to do this. I have no idea how to change 1 over cosec into that complicated looking left side. So in that case, let's start looking at the left side. And our basic strategy, we want to change the left side to make it meet somewhere in the middle with that. So let's try to do that. So basic strategy is when in doubt, change everything to sines and cosines. Tangent is the same as sine over cosine. And cotangent is the same as cosine, or cotan squared is cos squared over sine squared. Okay, so now this will cancel and one of those will cancel. This will cancel and one of those will cancel. So we're left with cosine of x over cosine of x over sine of x. And dividing by that fraction is like multiplying by the reciprocal. The reciprocal of cos over sine is sine over cosine. Those will cancel and we're left with sine. And now let's go back to the right side. 1 over cosine, 1 over cosec is the same thing as sine. So that was a good example of changing the right side. We got stuck, we didn't know where to go. We went back to the left side and tried to make them meet in the middle. And that's how it works. Alright, we'll do a couple more. Like I said, the key, the secret really to trig identities is just doing a lot of them. Eventually you'll come to a point where you've done so many that they can't really fool you anymore. You've kind of seen every type of identity. So verify by transform. Okay, so now the question, our first strategy is always start with a more complicated side. Now both of these look pretty complicated, right? But remember, here's another strategy that I want to point out. Start with a more complicated side. Okay, if you get stuck, you might have to go back. Use all the normal algebra techniques, factoring, etc. Okay, so that's what I'm going to try to use here. So on the left side, I don't see anything that would really help us. On the right side, we have stuff to the 4th power. On the right side, I do see a common factor, though. These both have a secant squared in common. So let's try and see if we can factor that out, and maybe that will get us somewhere. So if I divide this by sec squared and this by sec squared, I'm going to get 2 minus sec squared. Okay, and again, that still doesn't entirely help us right here. I'm not quite sure how to leverage that. So let's leave the right side alone for now. because sometimes you pick, maybe that wasn't the more complicated. So let's try the left side. And what I notice about the left side, see if we can make these meet in the middle. What I notice about the left side is that is a difference of squares. This is a square, and that's a square also. So let's see if we can factor this. So 1 times 1 gives us the 1. What did you square to get tan to the 4th? You must have squared tan squared. And then one of these will be plus, and one of them will be minus. Alright, so another strategy on our sheet is try to make well-known identities appear. And there is a well-known identity for this. 1 plus tan squared. Let's recall what that is. 1 plus tan squared, or tan squared plus 1, that equals sec squared. Okay, and that's a good sign, because we're trying to meet in the middle, and the right side has a bunch of secants in them. So if we can start making secants appear, that's probably a good thing. Okay, and then we want more secants to appear. We don't want any tangents. So if we look at tan squared, here's our identity. It would be nice if we could change that one into a sec squared also. So if we subtract 1 from both sides, we would get tan squared equals this right here. So that's what I'm going to use. I see a tan squared there. I'm going to subtract the equivalent right here, which is sec squared minus 1, and this might help us get a meet in the middle on the other side. So we get sec squared. Okay, that's equal to this right here, so at least we're set with that. And then if I distribute the minus, I would get 1 minus sec squared minus the negative 1 would be like plus 1. So that's going to be the same as sec squared times 1 plus 1 would be 2 minus sec squared. And sure enough, we just had the meet in the middle. Okay, that's a good strategy. You get stuck on the right side, try to do stuff with the left, have the meet in the middle. Alright, whoops. Let's do one of these. Let's just do a couple more. Again, the more of these you see, the easier it gets. So let's try, let's try this one right here, the harder one, number 2, because we did something similar to number 3 before. In fact, almost identical. So, whoops, let's clear these annotations. Okay, this one is kind of tough. We don't know exactly where to start here. Start with a more complicated looking side. And even though the left side might look a little bit more complicated, usually fractions tend to be more complicated. So I'm going to start with the right side. Okay, and then usually when you see a fraction, what you end up doing is splitting this down the middle. So let's do that. So we'll do sine over cosine minus cosine over cosine. One of the reasons I did that is I'm looking at the left side and I see a tangent here, and I saw a sine over cosine, and believe it or not, that equals tangent. So that's a good sign. Not sine like S-I-N-E, but indicator. Sorry, that was a bad pun right there. So there's tangent. We have that part covered. We somehow need to make this thing appear from minus cosine over cosine. Cosine over cosine is 1. So that looks challenging, but remember, one of our strategies is try to make well-known identities appear. Strategy number 2, let's go back. What's a well-known identity that has cotan squared and cosec squared? That's one of the Pythagorean identities. It's this third one, 1 plus cotan squared equals cosec squared. So let's write that so we have it to look at. Okay, and then let's try and see if we can make this appear. So cosec squared is equal to this. So I'm just going to replace, actually, sorry, we're on the right side, so we have a 1, so let's solve that for 1 right there. This would be another one where if we wanted to, we could make the meet in the middle, but it's not going to be hard to do that. So 1 is equivalent to that right there. It's equivalent to cosec squared minus cotan squared. So let's do that. Tan minus this right here, minus cosec squared minus cotan squared. If we distribute the minus, we're going to get tangent minus cosec squared plus cotan squared, and we're done. That right there is identical to that. The only difference is they put it in a different order. So there's the cotan squared, there's the tan, and there's the minus cosec squared. So that's now been proven identical. Alright, let's do just maybe 1 or 2 more from here. So I'm going to try to pick out the ones that look a little bit harder. Number 3 looks fairly difficult. 4 is very easy. Let's just do that right now. This is equal to sine squared, and sine squared over cosine squared equals tan squared. So that didn't take hardly any effort. This one we'll do 2 since we're here. If you FOIL this out, you get 1 minus sine squared, and that is equivalent to cosine squared based on this identity. Like we said, that one shows up all the time. So 2 and 4 are not so bad. 6 is also not bad. If you FOIL this out, you're going to get sec squared minus 1. And there's an identity which says tan squared plus 1 equals sec squared. So if you want to solve that for tan squared, you would subtract 1. Sec squared minus 1 is here. Tan squared is here. So 2, 4, and 6 were not so bad. 3 and 5 look a little bit tough. So let's try both of those. So number 3 is sine equals this big mess right here, and how are we supposed to simplify that? I think the easiest way, certainly when we have to pick the more complicated side, the right side is definitely more complicated. So I'm just going to write down the right side. And one of the strategies on the sheet says use all the common algebra techniques. So that, first of all, we can't split this down the middle because you can only split, like if the top were tan plus cotan, then you can split it. You can't do it on the bottom. So let's multiply the top and bottom by the conjugate right here and see if that gives us any idea of what to do next. I can see a couple ways you can do this, but this one seems like it might be the most promising. So we're going to have sec times this, and I'm not going to multiply this out just yet. And that's going to be over, when you FOIL this, it's going to be a difference of squares. You're going to get tan squared minus cotan squared, because the outside and inside terms are going to cancel each other out. Okay, so it's still not clear how we can, again, we're trying to make it equal the left side, which equals sine. It's still not obvious where to go from there. So when we're not sure what to do, probably the next best thing to do is to change things into sines and cosines. So let's try that. So secant is the same as 1 over cos. Tangent is the same as sine over cos. Cotan is the same as cos over sine. So let's see if we can now distribute this right here. And the bottom, we'll change those as well. The bottom is going to be sine squared over cos squared. That's tan squared. And then cotan is cos squared over sine squared. That's same as cotan squared. So let's distribute this on the top at least. So if we distribute here, we have 1 times sine would be sine. And cosine times cosine would be cosine squared. Okay, 1 time, and over on the other one, these will cancel, so we're just going to left with minus 1 over sine. And then we still have over sine squared over cos squared minus cos squared over sine squared. So we're still left with that right there. Okay, again, what are we trying to change this into? We're trying to change it into sine. So I don't know how much closer we are right now, but maybe slightly closer at least. So let's try to do a couple things. Let's combine the bottom. Let's make a common denominator here. Actually, let's do that with the top first. So this common denominator would be cos squared sine. So this is missing a cos squared, and so is this. And this is missing a sine, and so is this. So here's what we get. We're going to have sine squared over sine cosine squared. And sometimes you might discover as you're doing this, there's a much easier way to do this. I'm sure there probably is. But 1 times cos squared is cos squared. So other times you just have to kind of grind through this and see what you come up with. Okay, we still have over this thing right here. So that's over cos squared, and that's minus cos squared over sine squared. Alright, we have a common denominator on the top, so we can change that into sine squared minus cos squared, all over sine cos squared. And then let's change the bottom here. Let me use a different color. This is this huge green fraction bar. Let's change the bottom into a common denominator, see if that gets us anywhere. So this common denominator would be cos squared sine squared. So this is missing a sine squared, and so is this. This is missing a cos squared, and so is this. So this is going to be sine to the 4th. This is going to be minus cosine to the 4th. And now we have this big common denominator here, sine squared, cosine squared. Okay, we're trying again to make this into sine. That was the original goal. It may look like we're far away, but I think a lot of stuff is going to simplify. So we're dividing fractions. So we're going to take this right here, and we will end up multiplying by the reciprocal of the bottom. So the reciprocal of this would be sine squared cosine squared over sine to the 4th minus cosine to the 4th. Alright, so let's see what we can cancel here. We can cancel a sine here and one of these sines. We can cancel both of these cosine squares. And then this thing right here can actually factor. That's a difference of squares. That's the same as, what did you square to get sine to the fourth? You can't squared sine squared. What did you cancel to get cosine to the fourth? Not cancel, but square. You can't. You squared cos squared, and then 1 is plus and 1 is minus. Why do we do that? Because now that will cancel with that. So this is kind of a hint. If you see something like this on top, usually that's a sign that something on the bottom can factor to cancel that out, because it's uncommon to see things being raised to the fourth power. Alright, so now what do we have? We have sine, and we have this right here, and you should recognize that. That's an identity. That equals 1. So we have sine over 1, and that just equals sine, and that's what we set out to prove. So that was a long one. That was a difficult one, but like I said, there's probably might be an easier way to do that, but not one that comes to my mind at least. Let's try this last one. This is an identity right here. That's the same as sec squared. And this right here, when in doubt, will change to sines and cosines. So tangent squared is the same as sine squared over cos squared. And cosec squared is the same as 1 over sine squared. Those will cancel. We're left with 1 over cosine squared, and that equals, from our identity, secant squared, and that's identical to that. So that's section 13.2. The one thing I want to emphasize is it is difficult to do those problems. It takes a lot of practice, but the more of them that you do, the easier they will become. If you stick to these 4 strategies and follow them, pick the harder side, make the well-known identities appear, use all those techniques, factoring, conjugate, and so on, and when in doubt, change everything to sines and cosines. If you stick to those, it will definitely start to become easier.